Well, good afternoon and welcome to today's webinar where we're going to take a look at capabilities within Creo centered around model-based definition regarding general dimensioning and tolerancing within your models to just improve the overall accuracy of the models that you're making for machining purposes and just to have an overall better parametric CAD model. My name is Rob Romanowski. I'm the Director of Sales Operations with 3HTI. And I love doing these webinars every week. Thank you for the feedback that these are informative, helpful, educational. That's exactly what we want to provide and do for not just our clients, but anybody who is interested in learning more about Creo. So leading the webinar today is Paul Dye, who is a solutions consultant and applications engineer with the illustrious PTC Virtual Center of Excellence. And Paul does a great job with this for us, and I appreciate his help. And he's going to give you an overview, and then he's going to get into a demonstration, a live demo. If you have any questions, pop those into the Q&A box. We'll try to answer those as we go. If not, we'll answer them at the end. We're recording this so that you will have the access to the recording afterwards to view again at your leisure or share with a coworker. So with that, Paul, you have the con. Take it away.
All right. So just to confirm, you can see my screen, hear me okay?
I see your screen perfectly.
Awesome. So happy to be on, of course. If you haven't been on with me before, my name is Paul Dye. I'm a solutions consultant and application engineer here with PTC. And honestly, pretty excited to talk about today's topic, which is going to be a number of different things, but all centered around the idea of model-based definition. There's a lot of different capabilities that we really need to be able to focus on whenever it comes to speak on model-based definition. We have some specific tools such as the GD&T Advisor, which help us out with the application of our model-based definition and 3D annotations. But I'm going to go and kind of talk at a high level around all of these different capabilities. If you have any questions throughout this, definitely feel free to drop that into the Q&A. We'll be more than happy to take a stop and answer anything that you might need. If there's anything that goes out of the scope of what I cover or what I know, I have an extensive field network that I can reach out to as well. So anything that you're curious on, definitely feel free to ask on there as well. First thing I want to do is just start by going over some of the challenges that we typically see in the industry. First and foremost, around working with 2D drawings. 2D drawings have traditionally been the primary way that you have for transferring design information on your 3D model out to the manufacturing world. It's the way that companies have always done this, but the process has some inherent issues that you can't ignore. In order to use 2D to describe something that you created in 3D, you have to use a series of complicated drawings that are difficult to read, difficult to interpret the design intent of the model. It's also oftentimes a very manual and error-prone way of operating. It seems that reading these types of drawings is almost like a skill that's dying off more and more every year. And if you have any misinterpretation of the drawings that you're reading or working with, that can lead to delays, rework that you really need to be able to avoid. And it's all compounded by the fact that you're oftentimes going to have changes happening to that source 3D model. When those changes happen, you need to make sure that those changes have been properly pushed to all of the 2D drawings and done so in a manner that hasn't changed the intended design intent and the overall output that you're looking to get to. Obviously, a lot of challenges that we need to be able to address. And it's an area that we've seen a lot of companies begin to define all that manufacturing information, the dimensions, tolerances, right onto the 3D model itself using 3D annotations, or what you might refer to as model-based definition, or MBD for short. But we've also seen a lot of times out in the industry with different tools is that 3D annotations could be cumbersome to use in those tools. You simply don't have the ability to detail and dimension everything that you would typically need on a 2D drawing. And even if you're able to, it's very difficult. We've also seen in the industry a general lack of support whenever it comes to 3D annotations. A lot of companies have standards and rules that they need to follow, and they need their manufacturing documentation to include all of that. We also need to make sure that the people manufacturing our designs out on the shop floor can support any of the work that's being done on the 3D side. It's great if we can have all the dimensions and tolerances defined on the 3D model, but if the shop isn't able to take that in and use any of that information, we don't really have anything at that point. And last thing here is just seeing a general resistance to process change. 2D drawings, at the end of the day, have simply been a part of the process for as long as we've really done design work. And teams don't want to go through a painful conversion process to reach a state where all their information is ultimately defined by that 3D model. A lot of different things that we really need to take into account. And what we've done is take these different challenges and we're giving Creo purpose-built, or Creo users rather, purpose-built tools to effectively use model-based definition in Creo to address those challenges. This approach is enabling us to take and create 3D models that contain all of the data that we need to fully define a product and sharing it in a way that's easily utilized by a downstream consumer of that data. Looking at some of the capabilities here, this of course starts with full 3D annotations. In Creo, we have a robust set of tools that allow you to quickly and easily create and edit all of the annotations that would have traditionally existed on a 2D model. Things such as dimensions, tolerances, datum features, notes. All of this can now easily be defined right onto the model without having to switch over into a separate drawing file in order to define that. One thing that's a very key component here is combination states. And this is one of the tools that we have to create these clear, concise annotations. If you don't work with these currently, combination states in Creo allow you to view a model in different states, orientations, even different appearances that allow you to group and define annotations into a more clean and easy to understand format. What we want to do is move away from having these hard to read 2D drawings that have hundreds of different annotations all crammed together. Now we have that full 3D model that we can utilize and help to better organize the functional intent of those different annotations. Symbols are another key component of how we define the products that we're designing. In Creo, we work with a simple, streamlined user interface, replacing and editing symbols, creating custom symbols, and organizing our workflow to make sure that adding in symbols to our annotations is extremely efficient and easy to do. Looking at some of the different tools that we have, this is, again, a pretty broad topic. So we have specific tools that are built specifically for model-based definition to help us out here. One thing that we can use along with this as well is something called Creo Model Check. This is a powerful tool that we can utilize during the process to help ensure that any of your company standards or modeling best practices are being followed. Helps as people are getting up to speed with model-based definition and ensures that you don't have any mistakes falling through the cracks. On that note, not only can you ensure that your company best practices are being followed, we can also ensure that any 3D dimensions and tolerances that you've defined are following industry standards as well, whether it be ASME or ISO, we got you covered there. And ultimately what we're looking to do here is use all of this to help define the digital thread for the products. Essentially means that we want to have a closed loop between the physical products that we have out in the real world back to the digital information that defines the products. This is where you see companies working towards what's called model-based enterprise, where you have organizations using these model-based definitions, not just for manufacturing, but for all areas of the product, like commission, operations, service, all the way down to decommission of a product. You want that to all be defined back to that single source of truth, being the model. Now, everything I've talked about so far has been core capabilities of Creo Parametric that enable us to build towards model-based definition. But like I mentioned, we have some specific tools that enable us to do even more in that process. And one of the biggest things, and I'm going to cover this in detail today, is going to be the GD&T Advisor. What this tool is an extension that provides expert guidance on the application of geometric dimensioning and tolerancing, or GD&T, as well as validation that this work has been done correctly. And we'll see a couple examples of this. For example, if you were to apply a given tolerance on the model, what the GD&T Advisor will do is give you suggestions based off of that particular part or feature that you selected, and it's not going to give you certain options that you would not be able to apply, right? If you go to apply a tolerance and it would be invalid for that particular feature, it's going to let you know that. It's going to say, hey, that wouldn't be valid for this. Here's what we would recommend. Here's what's going to give you the most information and define that surface in the best way possible. It's a very useful tool. It also helps to educate users. It's going to give you context into any of the advice that you're receiving so you can better understand the changes that are being made. So we'll take a look at what that looks like in the context of Creo. A couple other tools I do want to mention here as well that play into the general landscape of model-based definition. We have easy tolerance analysis. This is a tool for evaluating the impact of the tolerances and dimensions on your designs. And you're able to do that well before the product would ever go out for prototyping or manufacturing. You're able to take all of the 3D annotations and look at things such as statistical results, potential defects, worst case scenarios, and even take a look at which annotations and tolerances have the highest contribution to those goals that you lay out on the model. If you do tolerance stack-ups, this is definitely something that you'll want to take a look at and make sure that if you have a use case for it, be able to use right from within Creo as well. One thing that I mentioned is the fact that we want to make it easy to consume the information downstream. One of the main ways that we have of doing that is with Creo View. If you've worked with this before or haven't seen it before, it's a free to use visualization and markup tool that we provide so anyone in the organization or even outside of the organization can view and interrogate the models without ever needing to open up the native authoring tool. From there as well, we also have some extended sharing options such as JT format and step AP 242 for anyone that prefers to work in a separate visualization tool. But ultimately, we're making that process of taking that information and viewing it downstream as easy as possible as well. Okay, so enough talking around model-based definition. Let's go ahead and take a look at what some of these different concepts actually look like here in the context of Creo parametric. All right, so we'll go ahead and pull up our Creo interface here, and let's just start out by pulling up the model that we're going to be working on. So in short, the idea behind model-based definition is that we're going to be transitioning from all the information that would typically exist on a 2D drawing, building that all into a 3D annotated model. In order to do that, we're going to need to come up with some way to share the information in an easy to access, easy to use, easy to consume method. So this is going to be taking into account different specifications for your ASME standards, ISO, and we're going to go through and create annotations. We're going to create GD&T, and we're going to look at how we present that information. And that's what you're seeing here with these combination states. It's a way for you to create a schema that allows people to consume that information much in the same way that you would have on that 2D drawing. So anything that would have been over on that 2D, you're going to see embedded right here in this model. So we start out with some basic combination states at the top, things like maps and properties, notes and datums. And as you move over to the right, we move into some combination states which define actual features. And this is where we're going to see annotations, dimensions, GD&T information. All of this is also very easy to create with these annotations. We can go ahead and create a new combination state, update different combination states if we'd like to. We also have the view manager where you can go through and put further content in there. If I want to add in a cross section, something along those lines, or add additional options for specific views, specific orientations, you're able to do that there as well. All those capabilities are built right into those tools. All right, let's go ahead and move here. If we need to go through and add in some features or add in some information, we can do this in a multitude of different ways. What we're going to do is start out with the annotations tab here in Creo. So we're going to go ahead and add in a note with pretty much almost all of our annotation elements. Everything's going to be supported for different semantic references, for example. Here we have the basic surface that this note is placed upon, but we also have the ability to do these semantic queries. So that was a feature that was added a couple revisions of Creo ago, but we can go through and look at some additional options or additional surface references. A number of ways of doing that through loop, surfaces, seed and bound, number of different selection tools there. We also have some advanced functionality for selecting and collecting all those different surfaces that you want to have those references on. For example, this one's going to be a particular note. And anytime that I work with a combination state, you're going to set an annotation plane that's going to dictate how that dimension or tolerance note is going to show up. You also have the ability to right mouse button and modify or do some tweaking of that orientation. Easy to do there as well. And here we're just looking at adding in some references. So for this one here, we have one of the counterboards selected. Now we want all four. And I can put in some additional text, just like I have always had the ability to in the past with dimensions. So that functionality is all going to stay the same. You can go ahead and put in your GD&T information. So here I'm just going through and putting in my tolerance. And once I put that tolerance in place, you can go through and tweak work with it. You can change the orientation to match up the way that you want it to look out in that field of view as well, whatever's going to look best for anyone viewing that down the line as well. All right, so that's looking pretty good. And I'm just going to drag it into a place that looks good there. And with the annotation tab, you can create your GD&T. It's a manual methodology. You go through and build it up based on your expertise and skill working with geometric dimensioning and tolerancing. So not really any rule checking here, but what it's going to allow us to do here is actually switch over into this tool, the GD&T Advisor. It's going to be a completely different story as of before, where you have that manual methodology and you do that with your skill or experience or industry knowledge. What this is going to do is help you out, and it's going to be an advisor and almost like a spell check. You can think of it for any of the model-based definition information that you're going to go through and place in. So we're going to go ahead and start to work into this here. And any places where it finds certain preferences or certain things that don't apply or don't match a rule set, it's going to give you some options for how you might want to fix that. You can see here, it's going to give you some information on exactly what's happening. It's going to prompt you into how you might go about fixing it and give you some of that information to help you out and give you some guidance on where you're going to go through and work here. Now you can see some of the different tolerance information. You can see there it's going to highlight on specifically the tolerance that it recommends for that particular feature that you select on. And you can go ahead and get that added in very quickly. And any of the areas that are highlighted in green there are going to be any areas that are going to be fully defined. And you can jump right back and forth between here. You can go through and edit some model properties here if you'd like to. If you want to put a general profile in the note for any of the less specific features that aren't as critical, you can go ahead and get that applied here. And now any of the areas that aren't otherwise specified are going to have a general profile defined there in the note. All right, so that's something that companies will often do, is detail out those critical characteristics on the model, and then for all the other surfaces, just apply a profile requirement. So that's just one way of doing it. Here we have a couple other places where some of the syntax may not be up to the latest standards. So this is where we can go through and in some cases remove those and just simply do an update if you'd like to. And from there, we can use the manage annotations tool to look for particular mismatched or unvalidated items. And by simply taking a look here, we can go ahead and see, okay, this is where we might have particular issues. It's going to highlight there in the model. And simply by selecting them and hitting update, what you'll notice is that it's going to change and put back in the requirement. And it knows how many instances that exist in the model. It's able to go through and automatically take care of that for us. And here under the unvalidated, you can do the same sort of thing. We can look and understand in this case, maybe we're going to do it a little bit differently from before. We're going to take a look at a tolerance feature, and we're going to use that size dimension option and use the auto match feature in this case. And that's going to map back up to the 12.3 dimension that we were just looking at. So we're able to go through and work on it from that perspective here as well. Now, maybe I found a few other things here, so I'll go ahead and put those in place. Maybe we're going to deal with those a little bit later. But what the tool does is it looks at all the different surfaces and features that are applicable to this particular model. Right? But since we have the cross section in there, it's going to ignore any of the ones that aren't shown, so we can continue moving forward from here. And now if we want to as well, what we can do is put a composite tolerance in place. This is where we can go through and make our different selections and what we'd like to place in there from our primary, our secondary, tertiary items with that. And once you have it all in place, if I want to go through and start to share this information, out, you can go through and print based upon different combination states. You can pick which of the states are appropriate to print. You can pick and choose the exact ones that you're interested in. One thing you could also use here is Creo View. So we go ahead and export this out to a view file. One of the things that you'll also be able to take into account or consideration is your recipe file, which is what we're selecting here. This can be set up in a way that it's publishing out your annotations, your combination states, and all the information correctly. So we can see that view and utilize it downstream, for example, over in Creo View. So this is an important piece of the equation. Anyone that might be in quality or manufacturing, purchasing, any of those downstream users who aren't necessarily Creo parametric users, they need to access to this information. So I want to make it accessible in this lightweight format and be able to publish all of the different combination states like you're seeing here and give other users the ability to view that information as well. One thing that we can look at here as well is the check function. So just like we've always had in the past where someone would take a drawing out in the field and they would take a red, yellow, green pen and mark it all up, you can do the same sort of thing here with the design check tool. So you're going to go through here and select which combination state that you're interested in working on, and you're going to be able to select on individual annotations. You can add notes as required to add additional content to help some people downstream, and then save this as an annotation set. What that'll do is get saved with the model, or if you're working with wind chill, get saved back into the wind chill environment with that particular iteration of the object as well. So a good look there at what that work might look like over in Creo View. Another thing that I want to quickly show here as well is the fact that we can also work on assemblies. So model-based definition applies not only to parts, but to assemblies as well. Here we have our model that we're going to be taking a look at here. I have my schema down at the bottom. This is my start part. So whenever I work on a part or an assembly, I can automatically get all these different combination sets preset for me. And I can very easily walk through this, or anyone can basically see all the information that's associated with it. And again, maybe I'll work through the annotations tab. And when I want to work with a dimension, I can just go through and query on some of the surfaces that I would like to work on. In this case, there's a couple different surfaces. I want to go through and dimension from the outer edge to the edge of this particular slot here. I can dimension where that location is. And in this case, we're just going to make that a base dimension. So we're going to control the slot itself, but with GD&T. The dimension itself is going to be a basic linear tolerance associated with it. So that would be in conjunction with that dimension value that we have there. And again, very easy to go through and build some additional geometric tolerances on top of that as well. Maybe in this case, I want to select some of the different features that we have here, some of the mounting feeds, to select the surfaces and place in my different references here. Go ahead and select that now to a particular assembly state or a particular view state, and place that right on there as well. So very easy to work with and very easy to go to find that information, not only over on the part information that we were working with before, all of this work can be very easily done here on the assemblies as well. Not only that, the GD&T Advisor is also going to be able to help us out over for some of this information as well. All right, that covers everything that I wanted to show for the demonstration portion of this. And if you have any questions or any insight based on anything that I showed throughout there, definitely feel free to drop that in the chat. But while you might be doing that, I just want to cover very quickly some of the main benefits that we have from working with model-based definition. First and foremost being clear design intent. The way that we're able to define and lay out 3D annotations in Creo leaves it much less up to the imagination and much less up to the user to have to try to interpret what's being done on a drawing. It's much easier to understand the features and the dimensions on the model. Collaboration and communication is also something that's greatly enhanced, whether it be for engineering, manufacturing, or any downstream users. We're utilizing the digital thread to connect each piece of the enterprise, and ultimately we're able to greatly improve the quality of our products. We're reducing the errors that are typically caused by unclear or complex 2D drawings, and at the end of the day, saving us time and cost in the long run. Okay, that covers everything that I wanted to touch on today. Obviously, there's a lot more that goes into model-based definition and the GD&T Advisor, but I wanted to give you just a quick look at what that workflow looks like and really the ease of use for some of these different tools. So with that, I can pass it back over to you, Rob.
Thanks, Paul. It's all about better, faster, and less expensive. It's making a better product, getting it done faster and out the door and in the market, in less time, less money, and with higher quality. So this absolutely, these capabilities within Creo absolutely help to achieve those goals. So I'll have the recording listed onto the YouTube page by tomorrow, and I'll send an email out to everybody with the recording. And I want to thank everybody for being on. And Paul, thank you very much. If you need any more detail for anything Creo or Windchill or PTC solutions, you can contact us at info, I-N-F-O, at 3hti.com, or just reply to the email invitation that was sent to you. Thanks, everyone, and have a great day.